record this meeting, and this is the screen I use to write stuff and draw stuff. In other words, this is the same thing I would use if we were in person. That would be A, that would be B.
Oh yeah, I remember this formula.
It would be C. Yeah, that's the Pythagorean Theorem. All right.
Yeah.
Let me pull up some of the stuff I had looked at here.
Yeah, I remember that formula.
Let's go to circles. Okay. All right. These are the same problems that I had in my book. Remember that I was drawing upon?
Yeah.
I've digitized them all into my computer. So let me do this first before we go any further. What's the area of a circle? What's the formula?
Of a circle, pi r squared.
Good. What's the formula for the circumference?
Oh, is that? Oh, it's
Same three characters, only in a different order.
diameter.
No, don't remember it that way. Remember it as a function of
2 pi r squared.
2 pi r.
Okay, 2 pi r. Yeah.
See, it's the same characters. You just take the 2 and put it in front. Hold on a moment. Shut my door so my dog's barking doesn't interrupt us. Okay, so what that tells you is that there is only one important variable for a circle, and that's the radius.
Yeah.
The radius tells you everything. If you know the radius, you know the area. If you know the radius, you know the circumference. Which means that if you know the area, you know the radius, which means you know the circumference. So there's three variables here. There's the area, there's the circumference, and there's the radius. If you know any of those three, you can figure out the other two. If I had a radius of 3, what would the area be?
Here would be well.
Plug it in. Plug it into the area formula.
Yeah. Well, I would need pi and then 9. So pi times 9.
Well, and we write that like that. Okay.
Yeah.
What's the circumference?
So the circumference would be 2 pi 3.
6 pi.
Basically. 6 pi, yeah, 6 pi.
Always multiply your numbers together. Now,
yeah, 6 pi.
The question is do you use pi or do you use 3.14? Well, you can't
I've used both. It depends on what my teacher says.
Exactly. Exactly. Pi is the better answer, incidentally. Pi is exact.
Yeah.
3.14 is an approximation. Even if I say 3.1459 or 1459, that's an approximation. In other words, if ever I write pi as a decimal, it's an approximation. So if I want the most accurate answer possible, I'll always use pi in the answer. Okay? Now, notice that I can go backwards here. Let's say the area is 25 pi. What does that tell you? And I want to know what the circumference equals.
Okay, so if the area is 25 pi, then that means, would it be pi, wait, the circumference would be,
Solve for radius. The three variables in circles are area, circumference, and radius. If you know the radius, you're going to know both the area and the circumference. So in this problem, they give you the area, which is going to allow you to solve for the radius. What's the radius if the area is 25 pi?
5 squared.
What's the radius? That's the radius squared.
Would it just be 5 pi then?
Just 5.
Or just 5, yeah.
Yeah, notice what happens here. In other words, I know the area is 25 pi, so I say 25 pi equals pi r squared. And then that's just an equation you need to solve. As with most of geometry, as I've said, you need to come up with equations and then solve the algebraic equation. Well, if I solve this equation, what do I get? The pi's cancel, right? I can divide both sides by pi. And then I get r squared equals 25, which means r equals plus or minus 5. But
yeah.
only plus numbers make sense in geometry a lot of times. And that's something you have to get used to. The rules of algebra apply to geometry, but when I get a plus or minus, obviously the radius can't be minus 5. So I throw that out, and the only answer is the radius is 5.
Yeah.
Now, once I know the radius, what's the circumference?
The circumference would be 10 pi.
Yeah. So it doesn't matter what information they give you. They give you the area, you can figure out all three. They give you the circumference, you can figure out all three. Or if they give you the radius, you can figure out all three. And by all three, I mean area, circumference, and radius. Those are the only three things that really make a difference when you're talking about circles, is area, circumference, and radius.
Yeah.
All right. Let's take a look at some of these problems. If the area of a, let's look at number 1, this one right here.
Yeah.
If the area of a circle is 64 pi, then the circumference of the circle is what?
The circumference of the circle would be,
Let's go through it. Make sure you go through it step by step.
yeah, I'd like to see the formula again. Okay.
Well, here's the steps. And remember this, in geometry, the first step should always be write the general formula. This is the general formula for area. Now tell me what the radius has to be.
Uh-huh.
In other words, the area is 64 pi, so I'm going to plug in 64 pi for the area. Now solve for radius.
8.
Good. So r equals 8. Now solve for circumference. What's the general formula for circumference?
Is it,
Remember, it's the same three numbers, different order.
2 pi r. So it would be 16 pi.
Exactly. So all circle problems tend to have this aspect to it. There's only 3 variables that matter with a circle. There's actually only one, and that's radius. And that's why when you told me that the circumference was equal to pi d, I didn't like that.
Yeah, I was thinking of something
No,
else.
it's correct. It's perfectly correct. That's exactly what the circumference is equal to. But D is not the key variable for circles. R is. So I much prefer this,
Yeah.
even though it's 3 characters instead of 2, it states everything in terms of radius. And when you're talking circles, everything is radius, okay? Forget diameter. If you're given a diameter, cut it in half. That's the radius.
Uh-huh.
Let's look at problem number 2. And I leave you to read these on your own, and it's better if you don't read them out loud, because when you're taking a test in class, you're not going to be reading these out loud. So it's better if you read them to yourself, interpret them, and then tell me how to go about solving the problem.
Okay.
So, first of all, what's the perimeter of the triangle? That's the distance from A to B plus the distance from B to C plus the distance from A to C, right?
Yeah.
That's what perimeter means. All right.
9? Wait, no, never mind. Sorry.
Not quite. If you
No,
draw
that's
this
wrong.
picture out, what's the distance from the smallest circle, which has a radius of 2? So it's 2 from there to there. What's the distance from there to there?
From
What's the
A to C or A to...
A to B?
1?
No, it's a radius of 2 from A to here, and a radius of 3 from here to here. So it's 5.
Okay.
You see that? YAB equals 5. In other words, they've told us we have 3 circles of different sizes here. Okay? And they've told us that the smallest circle has a radius of 2. Well, that means it's 2 from the middle of A to the edge of A. And then they've told us that the radius of B is 3. So from A to B must be 5.
Oh, I see. Okay. So then, and the radius of C is 4, which would equal AB would be 5. Hello?
What's B to C?
B to C would be 7.
Good. And finally, what's A to C, the third side of that triangle?
6.
All right. Add those 3 up and you got the perimeter.
Yeah.
All right, number 3. Can you see those okay, or here I can blow it up one more. There we go.
That's fine.
Okay. All right, in the above figure, the ratio of the circumference of circle B to the length of arc ADC is 8 to 1. What is the value of X? All right, I'm going to minimize that for a moment just to cover this topic a little bit. Ooh, hold on a moment. I guess the way I need to do that is this way. If I want to know the distance from A to B, They're not talking about this distance. They're talking about if this was a piece of string and you cut it at A and cut it at B and stretched it out, what would that distance be?
The diameter?
Well, it's not quite the diameter. Let's put a radius on this of 3. What's this mean?
It's a 90-degree angle.
So what part of the circle are we looking at?
A fourth.
Okay. What's the circumference of this circle?
Circumference would be 2 pi 3, which would be 6 pi.
What's a fourth of 6 pi?
Like 1.5.
It is 1.5. Incidentally, when we have our online tutoring sessions,
1.5?
you should have a calculator in front of you.
What?
You should have a calculator in front of you.
Okay. It's 1.5.
Yeah, it is. Because it's 1/4 of the circumference.
Yeah.
Okay. Well, what if I drew a circle like this? And that's 60 degrees instead of 90. In other words, this is 90 degrees. And this one has a radius of 3. What's the length of AB now? You knew that the first case was 1/4 of a circle, right?
Yeah.
How'd you get that?
By multiplying?
Well, by dividing 90 by 360, right? In other words, the whole way around is 360. So if we're only at 90 degrees, 90 over 360 is 1/4. So we want 1/4 of the circumference. In the second problem, how much of the circumference do we want? First of all, tell me what the circumference is in the second problem. Same thing.
The circumference would be 2 pi 3, 6 pi again.
Okay. Now, what's the measurement of AB in the second? And that's what these symbols mean. That means the measurement of arc AB.
Yeah, that would be so 6. What would it be? So you do 60 divided by 360?
You got it. 60 divided by 360 times 6 pi. Because what we have is 1/6 of the circumference. Well, what's 1/6 of 6 pi?
1/6 of 6 pi. Wait.
What is this answer?
1/6 or what? 1.
Just pi.
Yeah, just pi. Yeah.
1 is, I know what you meant when you said 1, but it's actually just pi. In other words, you don't lose the pi. When you're dealing with circles, almost always your answers are going to be in terms of pi. Because pi is, because it's the most accurate representation of that number, we rarely substitute 3.14 for it.
Yeah, I've only used that if a teacher puts that in the
and I don't know which teacher you're going to have in advance. So you may get a teacher that insists that you convert pi's to 3.14 every time. And you may get a teacher that insists that you leave it as pi, which is what my preference is, always leave it at pi. I hate it when the teacher says convert it to 3.14, because that's an approximation. pi is by definition the circumference of a circle divided by the diameter. And that number is not a number that can be written. I can try to write it, but I would just keep on going forever without ever repeating the decimals. Okay? So pi is a very unique number. It's called an irrational number. It's called a transcendental number. But basically, if you want to write pi in the most accurate form possible, you write it like that. Nothing else, nothing else is as accurate as that. All right, let's look at this problem here that's going to have to do with this. Hold on a moment. What happened to my drawing tablet? Apologize. I still getting a little bit used to Windows 10. Obviously not. Oh yeah, here it is. All right, one moment. Sorry. I used to use Windows Vista, and GoToMeeting said Windows Vista is no longer going to be supported by GoToMeeting, so I had to use Windows 10, and it's been hard for me to get used to it ever since. All right, so number 3, let's look at that. Upper right. In the figure above, the ratio of the circumference of circle B to the length of arc ADC is 8:1. What's the value of x? So in other words, the circumference of the whole circle, let me rephrase this problem a little bit. What if the circumference of the whole circle was exactly 4 times? In other words, what if the problem was this? And they said the circumference of the circle is 4 times the length from A to B. Well, what would x be? What would that angle be?
90.
Okay. So now they're saying it's 8 times. In other words, this problem says instead of 4 times, it's 8 times.
Oh, so that would be 45 degrees?
You got it. Yeah, I knew you had it. You just didn't say it. Exactly. Now, let's go through how we got that. In other words, the circumference of the circle, let's see. We want x is to 360 as 1 is to 8. In other words, whatever the proportion of x is to 360, remember when it was 90, that was 1/4. So x would be to 360 as 1 to 4, but in this case it's a 1 to 8 relationship.
X would equal 45.
Yeah, if you solve this equation, you get 8x equals 360 or x equals 45. In other words, all geometry problems can be solved by equations. And that's the way most of them should be solved. In other words, this should be your first step right here.
Okay.
Now, in this particular one, you were able to figure it out without writing an equation, and that's fine. Part of learning geometry is learning how to do that. We got time for one more here. Let me blow this a little bit.
Got 4 more minutes.
Yeah. The figure above displays 2 semicircles, half circles. one with diameter AB and one with diameter AC. You can see that.
Mm-hmm.
If AB has a length of 4 and AC has a length of 6, what fraction of the larger semicircle does the shaded region represent? Well, these are a little difficult. Let me go through it first of all.
1/3?
Maybe not. I don't know the answer, to be honest. The area of the shaded region is equal to what? The area of the big circle minus the area of the small. Big
2.
semicircle minus the area of the small semicircle. Notice my notation here.
Yeah.
And the subscript is important here. But if you look at the picture, you can see that the area of the shaded region problems are always subtraction problems. Okay?
So would it be 2?
Well, now hold on. We're going to have to figure out all of these to know what it's going to be. I don't know right away. Okay? The initial start of this problem is to figure out that shaded region problems are subtraction problems.
Uh-huh.
It's the area of the larger semicircle minus the area of the white semicircle. Gives you the area of the shaded region. Okay? So, what's the area of the big semicircle? What's its radius?
Its radius is 6.
No, its diameter is 6.
Wait. Oh, its radius is 3 then?
Okay. So what's the area of it?
The area of it would be
pi r squared.
Pi squared, which equals 9 pi.
Divided by 2 because it's a semicircle. It's not a circle. It's only a semicircle. So it's half a circle.
Yeah.
Now what's the area of the small semicircle?
4 pi?
Divided by 2.
Yeah.
Okay. So what's the area of the shaded region? What's 9 pi divided by 2 minus 4 pi divided by 2?
9 pi divided by 2 would be 3 pi. Oh, wait, no, it would be 4.5 pi.
Hold on.
Minus...
We have the same common denominator, 2. So all we have to do is operate on the numerator.
So 5 pi.
Divided by 2.
Yeah.
That's the area of the shaded region. Okay? Now, that's not what they're asking. They're asking what fraction of the larger semicircle does the shaded region represent? Well, there's the area of the shaded region, and to figure out what fraction, we need to divide that by the area of the large semicircle, which was that. 9 pi divided by 2. So this is the answer we're looking for, is 5 pi divided by 2 divided by 9 pi divided by 2. How do you do that math?
You do copy dot flip.
Sorry, I didn't hear that.
Copy dot flip.
Yep. So what's the answer?
It would be, let's see, 10 pi over...
Here's what you want to do.
Yeah.
I hate it when people do that because you don't need to do that. If I'm doing copy dot flip, this is what I'm doing, right?
Yeah.
Okay. Cancel before you multiply.
Oh, yeah. It would be 5 over 9 pi.
Just the pi's cancel, the 2's cancel. You get 5 over 9.
Yeah, so it'd be the fourth circle.
Exactly.
With 5 9.
Exactly. But this
Okay.
this is an important principle in algebra. Always simplify before multiplying. Because if I multiply, I'm going to get the right answer. I'm going to get 10 pi over 18 pi. But then I got to reduce that. And that reduces to 5 9ths. But if you reduce it first, it will leave all your numbers smaller. Notice that when I did it this way, I never dealt with a number greater than 9. Whereas when I did it this way, I had a 10 and an 18. Anytime you can keep your numbers smaller, you're always better off in math. It reduces the chance for errors. All right. As I said, this has been recorded, but in order to send you a copy of it, I need your email address, or let me just see if I've got one that I can send it to here. tim.griffith@almm.com?
Yeah, that's right.
That's yours? Okay.
That's my dad.
That's your dad's? You want me to send it to your dad's, or you want me to send it to yours?
Yeah, you can change it to mine.
Hold on a moment. Make sure I write that down. What's your email address?
Daniel Griffin.
One N?
Yeah, that's right. 16 at hotmail.com.
Okay. It takes my computer a few hours to process these files. I can't send them directly to you, but
fine.
Once it gets processed, I will send you a link, and you'll always be able to access the file of our session. It's just it's a recording in YouTube format, and I don't know, some students use it, some don't, but I think it's a useful tool, and what I'll do is by tomorrow morning you'll have a link sent to that email address that tells you how to see the recording of this session.
Okay, sweet.
Okay. All right, Daniel, I will talk to you next time.
Okay, awesome.
All right, bye-bye.
See you later. Bye.